The motorcycle rider today are always looking for more and more specific performance. It is clear that everybody expects a high level of the tire performance, generally speaking, but if you look for going straight or going in corners in straight direction, you expect more mileage. In cornering, you expect more grip. This concept has been attacked already in the past by using different compounds. So you can use a compound for straight, which is giving you more mileage, and a compound in cornering, which is giving you more grip. Metzeler, however, was inventing a different component. If you look into a tire, the tire is not only the tread compound, which you see from outside. It's also a belt and a structure, the carcass. The belt are fibers which are winded around the tire in a circumferential direction, and the carcass is below this belt allocated. If you change the carcass material and the carcass fiber, or if you change the belt, you influence the performance of the tire. From that point, it was during a research project coming out from the testing department that when we changed the tension of the belt, more precisely speaking, the tension of each wire of the belt, we influenced the performance of the tire. The performance of the tire in the sense that when we reduced the tension, we had a higher grip level, and when we increased the tension of the belt, we had more mileage on a standard grip level. Metzeler is calling this system interact. Interact because it's clear that the different components, carcass and belt and tread compound, are interacting between themselves. We used the system the first time on the new product at Z6 Interact. What we did was, in the center where we wanted to defend the mileage, we have a 0-degree steel belt with high tension, and the spiraling versus the shoulder of the tire is then continuously reduced to end up with a lower tension in the shoulder to support the grip of the compound. This is a much more smooth approach than, for example, using different compounds. Then you can use 2 compounds and you have a step from the first to the second compound. Or you use 3 compounds, then you have 2 steps from the first to the second to the third compound. In any case, in the concept of the 0-degree variable tension, it is a smooth change from the center to the shoulder. We tried to explain the system by developing a tool where we have an instrument where we can change the tension in the longitudinal direction, simulating the steel wire. So we can give lower tension and higher tension. And we can see when the tension is changed, then you feel a different stiffness in the surface, simulating the surface of the tire. From that point of view, we transfer a longitudinal tension into a different stiffness in the contact area of the tire. So this tool is very easy to understand and translates the 0-degree steel belt variable tension concept in detail.